Today's Daily Dose of Math is an intro video about the concept of correlation coefficient, also known as the R value. In statistics, sometimes we get data and we have the data in the form of X and Y coordinates. We're able to graph those points on a coordinate plane like this one. For my examples, I haven't labeled my X and Y axes, so we don't know what variables are being used here, what the meaning of them is. But we're focused on how these points are clustered together. These ones here are clustered together in a way that suggests a straight line with a positive slope that we can imagine running through the middle of those points. The same thing's happening here, except the points are not clustered quite so closely together, and we're imagining a straight line with a negative slope. The R value is a number that we apply to say how closely those points are landing to the imaginary line. R values have to be between -1 and 1. An R value of 0 means you have no correlation at all. We do not see any relationship between these two variables. A correlation coefficient of 1 is a perfect correlation, which means that the dots would actually all land right on the same line. A correlation coefficient of -1 is also perfect. The dots would all land on the same line, but the line would have a negative slope instead of a positive slope. In our course, Math 4152, we have a table. And the table allows us to judge how strong the correlation is by dividing the interval between 0 and 1 into 5 smaller intervals. Between 0 and 0.5, we say that is a non-existent correlation. We just do not find any relationship we can trust between this X and this Y. Between 0.5 and 0.75 is a weak correlation. Between 0.75 and 0.85 is medium. Between 0.85 and 0.95 is strong. And between 0.95 and 1 is very strong correlation. Although I didn't have room to show it on my chalkboard, the interval between 0 and -1 works the same way. An R value of -0.4 would be over around here on the number line, and it would be non-existent. An R value of -0.6 would be weak, etc. In my examples, I can estimate an R value. This is a guess, but when I look at this one, I could guess that perhaps I would have an R value of positive 0.86. So therefore I would be saying that this is a strong positive correlation. And this one I would guess has an R value of about -0.57, which would be considered a weak negative correlation. The concept of the correlation coefficient, the R value, is very important in this course, the Math 4152 statistics course, where we look at linear correlation in a lot of detail. We call it linear correlation because the shape that we see emerging from the group of dots is a straight line. We will practice a number of ways to look at data, decide whether there is a correlation, assign an R value to it, and judge the R value. That is today's Daily Dose of Math. Please like, subscribe, and share.